Alright, so in this video we are going to continue from where we left off last time. We will be looking at Matlab and then we'll be writing simple programs to basically practice some of the concepts that we had learned in the last video. Now if you do not have Matlab installed, then you can actually use Octave. Especially for the programs that we will be writing in this class, it really doesn't matter which software you're using. And also I'm going to show you that the program that you write in Matlab is going to run in Octave without any problems. Alright, so to open up Octave, just click on the desktop shortcut and then it's going to fire it up, and then you will be seeing a window like this. This is the default window that you will be seeing, and I'm actually using Matlab 2017A, and if you're using an earlier version, the buttons would look a bit different, but for the most part the layout hasn't changed. Matlab comes with this very classic layout. On the left hand side you have this current folder. That is the folder in which you are currently present, and you have this command window, which is an amazing tool, and then on the right hand side you have Workspace. Okay, we'll jump directly. So in Matlab the command window is like a calculator. You can test out your programming concepts, you can test out different commands in a very quick manner. Alright, so the first thing that we are going to do is we are going to create an array that contains 10 random numbers. Okay, so I'm going to say a is equal to rand of 1, 10. Alright, now what this command does is it generates 10 numbers that are all random, and they are randomly chosen between 0 and 1. Now rand is an inbuilt function, and what does this 1, 10 mean? Well, in Matlab everything is a matrix. Okay, so here 1, 10 means you are having one row and 10 columns. Let's go ahead and plot. Let's go and plot A, and then what we have done is we have actually plotted the random value, and you can see that in the X you are getting this index 1, 2, 3, 4, 5 and all the way up to 10. So by default what Matlab is doing is for the X data it's taking the index of the array. Alright, so what do I mean by index? So before I do that, one thing I want to say is throughout this course I would be using arrays and matrices, the terms interchangeably. So what's the difference between an array and a regular variable? Okay, so for example, let us say b is equal to 5. Well, here the variable b, if you don't know what a variable is, this is called as a variable. Okay, the variable b is holding a value called 5, and it holds only one value. Okay, on the other hand, if you take an array, it contains multiple values. So since you have multiple values, you need a way to access those values. For example, let us create an array called density. All right, 1001, 1002, 1003. Okay, now you can think of this as density in a simulation at 3 different time steps. At each time there is a density. Now how can you access the density at the 3rd time step? Okay, in order to do that we need to understand the concept of an index. So the index variable in an array tells us the location where each of these values are stored. So for example, if I say that my index is 1, that's going to give me 1001. Okay, because in the first location or in the first entry of the density array we have stored 1001. Okay, and similarly if I type in density of 2, then I get the second value and the third value. So here this 1, 2 and 3 are called as the array indices, and in Matlab and Octave or any other programming language it's very important to understand the concepts of arrays and index. So now here you can see that the command window is quite full. So if I type in CLC, that means that clear command window, it's just going to delete everything. It's going to clear the screen and I can start typing commands again. Alright, so in addition to this, what else can you do in the command window? Well, in the command window you can do mathematical calculations. So for example, if I have to say a is equal to sine of 30, right? Now before I do that, you can see that I've already defined a variable called a, and you can see that in the workspace, and that is exactly what the workspace is. The workspace basically tells you what are the variables that are currently active in this present session, and if you just double click on it, it's going to just show you the contents. Okay, it basically opens up a table, and then in the table you can see the values. All right, and you can close it anytime. Now in Octave, this feature might not work very well. Okay, so now watch what happens when I say A is equal to sine of 30. You can see that the value got updated here, and then here the value gets changed. So in Octave or Matlab, the variables can be overwritten. All right, so you need to be careful about that. And you can see that something interesting is going on here. You can see that sine of 30 is negative 0.9880. That is because the function sine computes the sine of an angle, and it expects that the angle is in radians. All right. Now, if you want to compute the same thing with degrees, you just need to type sine d. And as we all know, sine of 30 is 0.5. Sine of 30 degrees is 0.5. All right. And you can pretty much do the same thing. It has tons of other mathematical functions, exponential operator, and so on. Okay. Now the strength of Matlab is that you can do these operations on arrays as well, which is what makes it so powerful. All right. So one thing I can do is I can create an array. Let us say that my array is 1, 2, 3, 4, 5. All right. I can do this, or I can do the same thing by saying A is equal to 1:5. All right. Now what this does is, this is the starting value and this is the ending value, and it automatically says that the interval is 1. Okay, and then it auto generates my array, so which is a very nice feature. Well, then you might ask, what if you need an interval of 0.5? Well, you can do that as well. If you type in 1:0.5:5, it's going to create an array where the starting value is 1, ending value is 5, and the interval is 0.5. That's pretty neat, right? Without much coding, you are able to do this very easily. Now what I can do is, I can create a new variable b, and I can say b is equal to a. And when I do that, the contents of a just get copied over to b, as easy as that. And now let us do some math operations on the vector b. Now let us say that I want to calculate the sine of all the entries in the array b. All I can do is just type in sine of b, and then that's it. You're computing the sine of each and every entry. That is so powerful. And similarly, let us say that you have b, and then you want to add the number 10 to all the entries. As simple as that. Now similarly, you can also do multiplication. Okay, so let us say we multiply b by b itself. Okay, so if I do this, you can see that inner matrix dimensions must agree. So what does that mean? Well, as I said earlier, right, everything is a matrix. Okay, so if I do size of b, it's going to say that, okay, my matrix B has 1 row and 9 columns. Remember, the first parameter defines the rows, and the second parameter defines the number of columns, and size is also an inbuilt command. So obviously, you cannot multiply a 1/9 matrix with another 1/9 matrix. All right. Now, what is our intention here? Is our intention to just multiply corresponding elements. So what I mean by that is, if I have b vector like this, if I multiply b with b, are we expecting that each and every entry of b should get multiplied with the corresponding entry in b? In that case, that would be a dot product. Okay, so if you're familiar with dot product, which we looked at in the last class, we are basically multiplying only the components, right? So what I can do is I can do b star b, but then I just need to put a small dot in front of it. This is called as the element wise operator. Now you can see that 1.5 times 1.5 is 2.25, and 2 times 2 is 4. Okay, so well, Matlab has other powerful matrix manipulation feature. So for example, let me first clear this. Now remember, when I clear the window, the workspace variables are still there. However, if I type in clear b, then what's going to happen is that variable is no longer going to be defined, and it has been cleared from the workspace. So if I try to access b now, I'm going to get an error saying that undefined function or variable b. So now let us create the b matrix one more time, and let us talk about a new matrix operator, the transpose. So if I type in b transpose, that's it. My row matrix is now converted to a column matrix, right? So if I type in size of b transpose, you can see that it has 9 rows and 1 column, whereas size of b is 1 row and 9 column. So now what we can do is, right, we can take b transpose and multiply it with b. Now what is the matrix that we are going to get? We have a 9 by 1 matrix, which is b transpose, and a 1 by 9 matrix, which is b. So the resulting matrix should be 9 by 9. Boom, and that's it. So you can see that MATLAB comes with a lot of powerful features. All right. So what I can do is I can compute this and say that this is capital A. All right. So you need to remember that MATLAB or Octave is case sensitive. So here you can see that small a and capital A are quite different. So you need to remember that. And then what I can do is if I have to calculate the determinant of A, as simple as that. In this case, the determinant works out to be 0, but you get the idea. Calculating determinant is just one command. And this is very useful when you're actually doing computational fluid dynamics or finite element analysis, because you have to do a lot of matrix manipulation. All right, at this point, you should have a little bit of understanding about how MATLAB works and at least how the command line works. Okay, so now let us actually just develop on some of the concepts that we learned in the last video where we looked at several math concepts. Now, before I do that, one of the key drawbacks of typing all of your program content in the command window is that it gets lost. So what I mean by that is, for example, let me just close MATLAB. And then what I'm going to do is I'm going to relaunch it. So when I do that, you can see that my workspace is empty. So now if I type in A or capital A, those variables are gone. So which means that I need to retype all of my commands. And that is where Matlab scripts come to help. So let us create a script file, and I think the idea is going to be very easy to understand. So the script file is basically a text file where you type your program and you save the program. So even if you close MATLAB, the next time you open up the program, all the contents are going to be there. All right. Okay. So that being said, let's create a new script file. And then what I'm going to do is I'm going to start with clear all, close all, and CLC. So I'm assuming that you're a beginner in MATLAB, and what I would recommend is I would always recommend that you start with these 3 lines of code. So clear all is going to make sure that we clear all the variables in the workspace. So for example, if I have A equal to 5, B equal to 6, and C equal to 7, and before I run this program, I want to make sure that I clear all these variables. So the close all concept, I think it takes a little bit of time to understand that. But basically what close all does is, so for example, if I plot, and then what I can do is, if I type in close all, it's just going to close my plot. That's basically it. And CLC, we have already looked at it. It is just going to clear the command window. Okay. So as a beginner programmer, start typing all your programs with these 3 lines. There are some exceptions, but we'll talk about those later. Okay. So what is the program that we are going to write? Well, one of the things that we looked at in last class is vector functions. Now the concept of vector functions is easy, but then it helps a lot if you are able to visualize a vector field. Okay. And one way to visualize the vector field is actually typing code for that in MATLAB and then looking at it. Okay. So now let us actually open one note here. So this is the simple vector function that I'm going to plot. So these are the components of the vectors. You note that the z component is 0. So we can assume that this is a 2-dimensional vector. And you can see that the x component is a function of y and x. So depending on the position, your x component changes, and so does your y component. So let us try to solve this in MATLAB and let us try to visualize it. Okay. So to start with, what I'm going to do is, I'm going to define my x and y vectors. So what I'm going to do is I'm going to say x is equal to 0.1 and y is equal to 0.2. All right. Then what we can actually do is, I'm just going to open it like this so that I can see my function as well. And then what I'm going to do is I'm going to say, so v underscore x, which is basically the x component of the vector, is minus y divided by x cap square plus y cap square. So here what we are doing is we are using the exponent command. So for example, let us say x is equal to 2. X cap 2 is basically going to take the square of the number. Now this is another advantage of command window. Whenever you don't know what a particular command or symbol does, you can just go to the command window, practice it, and come back again. Now we can see that as I'm typing this program, you have this highlight. Here you can see that if I hover on top of it, it says terminate statement with semicolon to suppress output. Now in MATLAB, what you can see is that you get a lot of tips like this, mainly to speed up your simulation. Octave does not do that. Okay. So because one thing you need to understand is that Octave is an open source software, so it is not as well made as MATLAB. Okay. So it lacks some of these nice features. But what is the error here? So for example, if I type in x is equal to 0.1, notice that when I execute it, MATLAB just prints it back to me. Okay, that is the default behavior in MATLAB. On the other hand, the same statement, if I type it with a semicolon, the output does not get printed. Okay, so for example, let me just change the value here. All right, so you can see that x is 0.1. When I change it, the value is updated, but it does not get printed out. And in general, it's a good practice to add semicolon to all the lines. Now remember, in C and C++, adding the semicolon is important. If you do not do that, you are going to get an error message. In MATLAB or Octave, it's not required. Okay, so we have computed the x component of our vector function. And now let's compute the y component.